And again, we are going to back to our little pizza demonstration here. Little Caesar has square pizza, so we're going to use those because I don't want to work with circles. Okay, here is your Little Caesar's pizza. Obviously, it's just something stuffed crust with pepperoni, cheese, whatever it is. It is, you know, a 10-inch square. Okay, they offer that one, and they offer a bigger size, which is, the dimensions are twice as big. This is a 20-inch square pizza. Still, the pepperoni still stays the same size. It doesn't grow with the pizza. I'm taking a while to draw those pepperonis. And here's the question I think I posed this to you before. You know, if they sold this pizza here for, let's say it's one of those $5 specials they have. Okay. And they sell the 20-inch one for $15. You know, which one is your better deal? Well, if you're smart, you go with the big one, and here's why. Even though you say, well, this costs 3 times as much, but it's only 20 bigger. You have to remember what? Somebody gonna tell me what I'm gonna tell you? When you double something's dimensions, what happens to its area? Okay. Perimeter, let's look at the perimeter of both of them. The perimeter of the small pizza is, perimeter of the small is 10 plus 10 plus 10 plus 10, which is only 40 inches, right? The perimeter of the big pizza is 80 inches. Okay. Perimeter, since it is a linear measurement, okay, if the scale factor is 2, okay, the perimeter is also 2. But area is not a linear function. It is, you know, you are doubling this 10 and you are doubling this side. You're doubling this side and you're doubling that side. How many times bigger is this big pizza than this one? Well, what's the area of the small pizza? 10 times 10 is 100 square inches. The area of the big one is 20 times 20, which is 400 inches squared. So the deal is, and we've talked about this numerous times, when you have a scale factor of 2 and you have the area is the scale factor squared times bigger. And the scale factor here was times 2. If you square 2, 2 times 2 is 4, the new area is going to be 4 times bigger. And that doesn't matter whether it's a circle, a square, a rectangle, or whatever. If you double 2 dimensions, it's like you're doubling it and doubling it. And that's pretty simple to see because if I could, you know, if you look at this, if you look at this, and I copy this, and I paste it, I'm not going to be able to grab it, am I? Try this again. Paste. All for an object lesson. I got it. And I put it over here. Wait, what corner did I grab? I mean, you can tell it's going to take 4 of those to make up that pizza because you are doubling this side and you're doubling that side. So you shouldn't, and you really don't even have to really draw these things when I ask you a question. Let me, oh, that's nice. Let me give you a problem from the book here. Oh wait, maybe I have to do more. Oh, sorry. And then volume. Let's just talk volume first. Volume is the same kind of idea in the sense that how many dimensions do you multiply together to get volume? 3. If all 3 of those dimensions are doubled, you know, let's say my pizza, let's say I could buy a cubic pizza. Well, I guess it wouldn't have to be cubed. let's say my pizza is 1 inch thick here. And I double that, so my new pizza is 2 inches thick. Okay, what is the volume of the small pizza? 10 times 10 times 2 is 200, whatever, cubic inches. The volume of my big pizza is 20 times 20 times, if I double 1 inch, it's 2. 20 times 20 times 2 is, 20 times 20 is 400 times 2 is, did I do something wrong? Double 20, 400. Did I say this was 1 inch? Oh, I wanted somebody to say it. This is only 100 inches. Keith, were you thinking that?
Yeah.
Okay, well, thanks for that.
Sorry.
The new one is 20 times 20, which is 400 times 2 inches wide, which is 800 cubic inches. How many times bigger is the new one? 8 times. And why is that? Because volume is the scale factor cubed times bigger. Because your 3 dimensions are getting doubled. You double, you double, you double. That's 2 times 2 times 2. That's 8 times bigger. Now, let's look at one from the book here. I got one. Look at page 613. Let's just look at letter B. The dimensions of a wallet-size photo are about half the dimensions of a 5 by 7 inch photo. The area of the wallet-size photo is about what fraction of the area of the 5 by 7 photo? Let's just look at that. So you've got a 5 by 7 photo, right? The new photo, it said, was about half the size, right? So my new photo, and it really doesn't matter. I mean, you could cut 5 in half and get 2.5, and cut 7 in half and get 3.5, and do all the math. But all you need to know is what the scale factor is. What is my scale factor from the big one to the small one? What am I doing to this one, to this one? What did I just do? Well, divided by 2 is the same as multiplying by, oh boy, 1/2. Remember, it said it was the half the size. Okay. Both of them are halves. And we know when you talk about area, you take the scale factor squared to find out how many times bigger. What is 1/2 squared? 1/4. The new picture is 1/4 of this, because it's the scale factor 1/2 times 1/2. It works when you multiply by whole numbers, or when you multiply by fractions, it doesn't matter. This one's smaller. It is 4 times smaller than that one is. Okay, that is 1/4 of. The area is 1/4 of. I know you're excited about that, so let's pick another one. How about letter E? Find the surface area and volume of a 1 inch cube and a 10 inch cube. What is the ratio of their surface areas? What is the ratio of their volumes? Well, so what would you do? You would draw your 1 inch cube, right? And then you pretend to draw your 10 inch cube. You probably can't because your paper's not quite that big. This is 1 inch by 1 inch by 1 inch. This is 10 inches by 10 inches by 10 inches. Does it say to find their volumes? It does it not? Oh, it doesn't say. What is the ratio of their surface areas? Again, you don't need to do this because you just, first of all, you can say, what is my scale factor? What is the scale factor? To go from 1 to 10, what's my scale factor? Midge? 10. My scale factor equals 10. Okay, you don't really need to do more calculations than that. It then says, what is the ratio of the surface areas? How do their surface areas compare? What do you do to the scale factor? For area, you square it. So the new cube is how many times bigger? What is 10 squared? 100 times bigger. Now you're saying, but that's not a ratio. A ratio is a fraction. Yes, it is. Well, here's your ratio. What 1 on the small cube is going to equal what on the big cube? What's 100 times bigger than 1? Okay, now, here's your ratio. If it's smaller to bigger, your ratio is, no, if it's bigger to smaller, no, smaller to bigger, 1 on the small is this way. If it's bigger to smaller, it's 100 over 1. Depends on what they're asking for. They don't know if they even asked you, did they? Should they ask you? What is the ratio? Oh, yeah. What is the ratio of their volumes? It is, where does it say? Yeah, 1 over 100. What is the ratio? What is the ratio of their volumes? This is the area. Volume is scale factor what? Q. So what's 10 times 10 times 10? Alright? The volume is 1,000 times bigger. You can get 1,000 of these, which is actually what I have here. This and this. Here are your, one of these little cubes. This is 1,000 times bigger, and that's the ratio. You don't even have to do any of the multiplication in the calculator. That should excite you to some point.